trendsetters, welcome to today's Grade 12 Maths Show. Today we have a special revision lesson on number patterns. We have selected highlights of lessons shown early in the term to help you revise Term 1's work. Please post all your questions and comments on our Facebook page on facebook.com/LearnExtra or on Twitter @LearnExtra so we can help you with your revision. Don't forget to download today's show notes on learn.mindset.co.za or click on the link on our Facebook page. Now it's time to get on with our lesson.
It says given the arithmetic sequence. So now what's nice about this question? Whenever you get a question in the exam, read it and highlight what's important. They said given the arithmetic sequence. So if they're telling me it's arithmetic, I already know that I am working with either Tn equals A plus n minus 1d for the term, or I'm working with Sn, n over 2, 2a plus n minus 1d. Because they've told me it's not geometric, they've told me it's arithmetic. Now we go to the sequence. And the sequence there says 23 plus 23 comma 27 comma 31. So if I look over here, 23 to 27, I'd have to add 4, and here I would have to add 4. So yes, it is following what they said, it is arithmetic. Now what I'm doing is what we call coding. So I'd say it's arithmetic. A always stands for the first term. Now the first term here is 23. And the D, as we found, is the common difference, which we found to be 4. And what I've done is I've actually written in code or in symbols what I know about the sequence. Now, what's the question asking me? It asks me to find the 27th term. Now, why I liked this question is it brings home some little thing that everybody has trouble with. It says the 27th term, but there is a term that is 27. And that seems to confuse people, so don't let it confuse you. It's something we can avoid confusion on. If you look at that, that is actually term number 2. Because if I'm looking at it, this would be term 1, this would be term 2, and this would be term 3. So in actual fact, term number 2 is 27. But we are asking here for term 27. So in other words, if I kept on going, I would get eventually to term 27, and that's what I'm trying to find. Now, as soon as I've decided that, as again, it's what I call coding. Sorry, I just want to make this extend if it'll behave itself. What will term 27 look like for an arithmetic progression? Well, we know that it's going to be A plus n minus 1. Do we know what n is? Yes, n is 27. And over here, in fact, we could say n is 27. So it'll be 27 minus 1 times the difference. But the good news is we do know what A is, and we do know what D is. So if we go over here, the A is 23. 27 minus 1 is 26, and the difference is 4. So that's not difficult at all, because now I'm going to say this would equal 23 plus 4 times 26, which is 104, I hope, which is going to equal 127. I hope I've worked that out correctly, but I won't check it. I think it is right. If anyone thinks I'm wrong, please go and send to Facebook and say you've done that incorrectly so I can check the arithmetic. But I think I'm right on that. So in other words, term 27 is 127. And it seems like whoever designed this question really liked 27 in it. Right, so we were busy with this and we had talked about term 27, and now they turn around and they say something new. They say which term equals 243. Right, so which term, so they want to know what term n is equal to 243. Now what does term n look like? It is A plus n minus 1d. Now what you'll always find with these questions is that there is at least, well, there always will be one thing you're looking for, and you will have all the other details, even if they be disguised. This one's not disguised because we've already done the A part, where we found our A and our D. So if we go over there to the A part, I think our A was, if I remember rightly, yeah, it's not too far to look. A was 23, and the difference was 4. So we know that information. What we don't know this time is what the nth term is. So we can say 23 plus, and as I've said to you, the unknown is this bit. So we can go open brackets n minus 1 times the difference, which is going to be 4, equals 243. Right, now, all we've got to do is solve this. Now, you know, you've got a choice of 2 ways here. The best way for me is not to multiply out the bracket. But if you prefer it, I'll show you both, and you can decide what you prefer. I think I'll show you, first of all, how to do the one where you don't unpack it. So what you would do is you would leave your n minus 1 alone, and your 4, and you would bring your 23 over this side. So now you have n minus 1 times 4, and if you take 243 minus 23, it's going to be 220. Right, now once we're here, we can see that in order to lose that 4, I need to divide this side by 4 and this side by 4, because after all it's an equation. So we have n minus 1 equals 220 divided by 4. Well, 4 goes into 22 5 times, that's going to be 55. And of course your calculator can help you, but I just want to encourage you to start very early to try and work without your calculator. If it means you're going to get the question wrong, then rather use the calculator. But certainly in your classwork, I'm encouraging you to try and work without the calculator, because all these tests that you do for university, you know, as NBTs and that sort of thing, rely on you not using a calculator. And it's also good for your mind, to stimulate your mind, to try and use your mind rather than a calculator. Right, so n is equal to 36. So what am I saying to you? Sorry, not 36, 56. I'm saying to you that term number 56 is 243. Okay, in other words, if we looked along this little list of delightful terms we've got here, eventually we'd find 243, and that would be term 56. So just don't get confused when I give you the term of 27 versus the 27th term. Right, let's look at another question and see what this one has for us. Now this one says, find the sum of the following finite series. Now before we even start, what does finite mean? Well, hopefully you're all screaming at the TV. Finite means ending. Infinite would mean non-ending. Okay, so if I talk about an infinite series, I'd be saying that this thing carries on forever, but this one doesn't. Have a look at what it does. It stops at 122. So that's why they say it's a finite series. Do they say to me what kind of series it is? No, they don't. They just say it's a finite series, find its sum. So immediately what I said to you is, remember, read and circle or highlight what's important. So they're asking for the sum. So that means we're either working with this formula, or we are working with this formula. And remember what I told you about this formula? There are 2 possible ways we can write it, so I'm just going to write one down for now. How we decide which one we're going to use is by deciding what type of sequence this is, or series in this case, because we've got add signs between it. So if we go to it here, it starts in, it says 2 plus 6 plus 10. So I would always check first for an arithmetic. So I'd say, if I move from 2 to 6, what am I going to get? And hopefully you realize that I would add 4. If I move from 6 to 10, looks like I'm in a winning streak. I'm also going to add 4. And once again, I'm going to add 4. So that decides me that it's not a geometric, it's an arithmetic. And now I just want to spend a few seconds talking about your formula sheet. The formula sheet is a very useful thing. But as matric, speed is important. So something that you use a lot, like these formulas, it often is a good idea to just know these formulas. And if I'm not much mistaken, I think when you write those MBTs for university and that, they don't let you have a formula sheet. I might be wrong on that. I'm not convinced I'm right there. But in actual fact, if you know your formulas, it's always easier to work with. What I would do with my formula sheet is I would keep it for in case I forget. Because, you know, everybody can have moments like that. But if I know it, I'd rather put it down. If you are kind of the person that will make a mistake, rather check it. Always just know your strengths and weaknesses and then use it to your advantage. So as I've said, it's arithmetic, so that is the formula I'm going to use. Now, what is in this formula? We have an A, we have a D, and we have an N, and we have an SN. So what are they asking me? They're asking me for the sum. Now, do we know N? And I hope you're saying, no, we don't. Do we know D? Yes, we do. D is 4. We've worked that out. Do we know A? Well, the A is the first term. Yes, it's 2. We know that. And we asked for the sum. So do we know that? No. So we have a problem. Of the 4 things in this formula, we only know 2 of them. So we must have a way to work out the third one in order to use that formula. Now, looking at this, what can we still work out? We've got A and we've got D. We don't know what N is. We're asking for the sum. They're asking for that, so the chances are we have to work out that. Now, how do we do that? Well, we know that this is term number 1. We know that this is term number 2. We know this is term 3. This is term 4. And in actual fact, this must be term N. Because if I was saying to you the sum of 5 terms, it would mean take term 1, add it to term 2, add it to term 3, add it to term 4, add it to term 5. So I would stop with what the number is. So that is term N. Now, does that help me? Because I've got a formula for term N. What does the formula for term N look like? Well, let's just get some space here. I'm just having some fun dragging this down. There you go. Well, this formula would be Tn equals A plus n minus 1d. And what do I know on this formula? Well, I do know A, as we said it's 2. We don't know n. We do know d, it's 4. But do we know this? Yes, we do. It's 122. So we're going to put 122 in there. Now, knowing that, we only have one unknown, which is n. If we solve that n, we can then go to the other formula, because now we know 3 of the 4 things. So what helps is to put on the side what you need to find and then to say, what have I got? And it helps you direct yourself. So over here we have 122 minus 2. And remember what I said to you about the n minus 1 times 4. This time I will show you the other way as well. So 122 minus 2 gives you 120 equals n minus 1 times 4. Now, as I said to you, you would have a choice of doing this one of 2 ways. The first way is the way I would do it. I would say, let me divide both sides by 4. So 4 into 120 goes 30 times, equals n minus 1. So n is equal to 31. The other way is to say, well, this is 120 equals 4n minus 4, which means we have 120 plus 4 equals 4n, which means we have 124 equals 4n, which means we can divide both sides by 4, and that's going to give me 31 is equal to n. Now, as you can see, it made absolutely no difference which way I did it. The one was just a bit quicker. But it's really about what you're comfortable with. If you're one who prefers to times out and then simplify, that's fine. Nothing wrong with it. I prefer to work with a bracket as a unit. It just makes it easier for me. But it's really your choice. You're the person who has to write that exam. Right, so back we go to the actual question we were asked for. We were asked for the sum, but we now know that this answer over here is term 31. So we know that A is 2, D is 4, and N is 31. So let's go on with the question. This board has been very unobliging when it comes to paging up. There you go. So as I said to you, Sn is n over 2, 2a plus n minus 1d. Right, so now in the light of that, let me just erase this little mess over there. In the light of that, we are looking for the sum, and we know there are 31 terms. We don't know what it is, but we do know that the n is 31, so it's 31 over 2. 2 times my a, which I think was 2 if I remember right. Let me just make sure. I'd hate to tell you how it is 2. 2 times 2 plus, now this is n minus 1, well it was 31. 31 minus 1 is 30. And again, you don't have to miss steps. I am inclined to do that because it actually looks easier to work with if you do it like that. but really don't miss steps if you're not sure. Right, so now 2 times 2 is 4, and 30 times 4 is 120. Right, so now once we're here, okay, let me just get this to extend again, and I see it's been very obliging. Right, here we are. So it's 31 over 2. Now notice what I'm doing. I'm deliberately not multiplying it in. I'm leaving it like it is. I'm going 31 over 2, and I'm going to work out my bracket first of all. So 4 plus 120 is 124. Now why did I do that? Because it makes my arithmetic a little bit easier. I've got 31 over 2 times 124 over 1. That goes once, and into there it will go 62 times. So I want 31 times 62, and now I'm going to be lazy and use the calculator. I think that's a good reason to use it at that stage. So it's 31. Okay. Obviously I'm doing something crazy with this calculator. Okay, it doesn't look like the calculator and I are going to get on. Anyhow, it's 31 times 62. Since the calculator won't work for me, let's use my brain if all else fails. So we got 62 if I times by 1, and if I times by 30, it's going to be 6, and that's going to be 18. And if I add that up, it's 2, 2, carry the 1, 9, 1. So I end up with 1922. Okay, and that's the end of the question. Have I found the sum of 31 terms? Yes. Do I like that question? Yes, I do, especially if I'm the examiner, because I've tested, do you understand what that last term stands for? And second of all, I've tested, can you do a term and a sum in the same question? And can you identify what kind of sequence it is? So I think it's a great question if you're the examiner.
All right, Mindsetters, I hope you guys are enjoying this revision session. Remember, if you are struggling and need help, please post your question on our Facebook page or send an email to helpdesk@learnextra.co.za. Now it's time to take a quick break, so don't go anywhere. We'll be right back. Welcome back, guys. I hope you are getting into the idea of revision. Please let us know how you are doing. I'd love to chat to you on the page or on Twitter. Enough of the chat. Let's get back to the revision.
The fourth term, so T4, is 55. So what I've done is I've just changed this whole sentence into code. And the 10th term is 45. So now I'm going to change that to code. And the 10th term is 45. So T10 is 45. Did they tell me what type of series? Yes, they did. They said arithmetic. So if it's arithmetic, we know already what formula we need. We need Tn equals A plus n minus 1d. Okay, now it says find n if, and I think there's something missing there, I think it should have been Sn, I think it's Sn, I hope I'm right, is less than 0. Sorry, I didn't notice that missing on the notes. So I think it says Sn less than 0. Right, so let's have a look at it. And what we're going to do, well, we know it's arithmetic. We know that's how the formula looks. So the first thing I want you to do is, while you have a break, which will happen shortly, is to try and do it yourself, but I'll set you up to start. So what will term 4 look like? Well, you can go back to that, but I get a bit lazy after a while. I say, I know that every time I have a arithmetic series, there's one less difference than the number of term. So if I'm looking at term 4, it's going to be A plus 3D. And of course, that's possible because the 3 comes from 4 minus 1. And term 10, well, that's going to be A plus 9D. And if we do that, we can see where this question is going to go, I'm sure, because you're going to try it while you have a break shortly. We are going to know that 55 equals A plus 3D, and 45 is equal to A plus 9D. So So how many unknowns have we got? We've got all of these. We know those. We know those. What we don't know are those. If I call this equation 1 and I call this equation 2, I can solve simultaneously. So I could take equation 2 minus equation 1. Now, you can, of course, make A the subject of the formula and substitute, but I find with arithmetic sequences the best thing to do is elimination. So what I would do is I would say 45 equals A plus 9D, and straight underneath it I would go 55 equals A plus 3D. Now I'm going to subtract those expressions. 45 minus 55 will be negative 10. A minus A falls away, and 9D minus 3D is going to be 6D. So now, if I want to work out this next bit, I would know that D is equal to minus 10 over 6, which is minus 5 over 3. Right, so knowing that, that's fabulous. Now all I have to do is go back and get the A, because now I've got the D, and I have to go back and get the A. Now it's up to you. In this case, I probably would go for equation number 1, because a 3D is going to be easier to multiply than anything else. So I'm going to substitute in equation 1. Notice how I'm giving my marker instructions. So I'm telling the marker, this is what I'm doing, and it helps them to follow my thinking. And I'm sure you've been well trained in that, because most teachers will nag you for that one. Okay, so what I'm doing here is I'm going to say 55, oops, that's what happens when you touch the screen when you're writing. 55 equals A, which is what I'm looking for, plus 3 times the difference, which is minus 5 over 3. Now that's 3 over 1, so that 3 divides into that 3. And now I have 55 equals A minus 5. Very nice, because even if I'd used the other one, 9 times 5/3, the 9 and the 3 would cancel down, and so it would make it easier to work with. So it's a good question. It's not going to cause huge problems in terms of our arithmetic. And so our A is equal to 60. So now I've got A is 60. D is negative 5/3. And I need to go back and just make sure I've answered the question. Always check that, because you can sometimes get carried on. We haven't. It said find n if Sn is less than 0. So let's go to the actual thing now. They want Sn less than 0. Right, so now they're solving for n. Sn is n over 2. We obviously don't know what that is. We do know A is 60, so it's 2 times 60. Plus n minus 1, we don't know what it is. And the difference we do know, which is minus 5/3. In fact, I think it's Tn. In fact, I'm pretty sure it's Tn. Sorry, I'm going to change it because I'm sure it's Tn. I meant to check that in the break and then didn't. But it's fine. It'll serve the purpose we want anyhow. So let's make it Tn less than 0. So Tn is going to be A plus n minus 1 D less than 0. Now A is 60. N is what I'm looking for. And the difference is minus 5/3. And my advice to you is keep that in a bracket, because you don't want to get confused about whether you're multiplying or you're subtracting. So if you put it in a bracket, you are sure that you are multiplying. So once we are here, we're now ready to solve it. Now what I would do in this case is I would multiply the whole thing through by 3. So if I do that, 60 times 3 is 180, plus n minus 1, and if I times by 3, it's just going to be minus 5. And of course, if I times 0 by 3, well, that's what it is. So what have I got? I've got n minus 1 times minus 5, and I'm going to bring this over as minus 180. Now, this is a great opportunity, because if I divide both sides of an inequality by a negative number, we know that the inequality reverses. Remember back to the good old days when maths was easy? No, I'm only teasing. It's easy still. We just got to keep it going. If I had 3 is less than 6, and I divided both sides by negative 1, Well, I get minus 3 and I get minus 6. And would that still be true? No, it wouldn't. It would be that way because a negative 3 is bigger than a negative 6. So we just remember the rule. If we are dividing or multiplying by a negative, reverse the inequality. But if you're never sure, just do a little sum on the side and make sure in your mind why you're doing what you're doing. So what I have now is n minus 1 is less than changes to actually greater than. In fact, I'm going to change the color pen to distress the point. And if I now take minus 180, divide by minus 5, it will be positive, and it would be 30, and that would be 36. So your n is greater than 37. And once again, you could times it out and then collect it. It would make no difference. And so I know that n is greater than 37. So only after the 38th term would it be less than 0. So as we're going, we're only going to start becoming negative at that stage. Question 5. And as you can see, this one is a geometric sequence. Is it nice? Yes, it is, because they've told me it is geometric. And so remember what I said, you always look for the important cues we find in the words. So if we look over here, this is geometric. That's term 1, term 2, term 3, and it's geometric. And they want you to determine in simplest exponential form, which is good news, which means I don't have to dig out the calculator. I can leave it as an exponent. Term 11, and which term equals 2, 4, 5, 7, 6. Now, term 11 would be a r to the 11 minus 1. Remember what I said to you when we were doing arithmetic? I said the difference is always 1 less than the number of the term. Well, this time the exponent is always 1 less than the number of the term. So in actual fact, term 11 is a r to the 10. Right, so the a would be 3/4. And r we haven't ascertained yet. Now remember, we can just look at it and say, what are we doing, and work it out like that, but we can also use the formula I've shown you. In other words, r is equal to term 2 divided by term 1, which is 3 over 2 times 4 over 3. That goes once, that goes twice, that goes once, that goes once, and the answer is going to be 2. So r is 2, so it's 2 to the 10. Now they said you leave it in exponential form, and so if we do that, it's going to be 3/4. Well, in fact, yeah, let's just leave it like that, 2 to the 10. And what do we know about 4? Well, 4 is 2 squared. So it's 3 times 2 to the 10 over 2 squared, which is going to be 3 times 2 to the 8. And that's perfectly acceptable because they asked me to leave it in exponential form. Of course, if they didn't ask you that, you could just work it out on your calculator. 2 to the 8 is not too bad. The next one definitely would be one I need the calculator for. It says, which term equals that? So which term? So term n equals 2, 4, 5, 7, 6. Term n will have the form ar to the n minus 1 equals 2, 4, 5, 7, 6. Right, now knowing that, let's just get this thing to extend. A little bit too much, bring it down. We know what a is already. A is going to be 3/4. The r is 2 to the n minus 1, and this is equal to 2, 4, 5, 7, 6. Right, now, if we're going to solve an exponential equation, which is what this is asking, you can remember back from grade 11 that what we try to do is get the bases the same on both sides, because then we can equate the exponent. So looking at that, I would times this side by 4, and this side by 4, and I would divide this side by 3, and I would divide this side by 3. So in actual fact, that falls away. So I have 2 to the n minus 1 equals, and over here, 3 will go once, and into there it will go, 3 into 24 goes 8 times, once, 9, 2, and then 4 times that is going to be 8, 6, I'm being very good without my calculator today, 7, and 2, 4. Now, what I would have to do is write this as 2 to some exponent. Now, you're going to do a section this year called logs. And logs will enable you to work that out a lot quicker than what I can do now. So what I would do is I'd go to my calculator and I'd take an educated guess as to how much the exponent was. So I bring up my calculator, I clear it, and I'd say let's try 2 to the exponent 18 and see what happens. Right, it's not quite 260. So let's divide by 2, see what I get. No, so obviously I've done something silly. Of course, there is another way I could do it. I could take this number and prime it, but again, it would take quite a while. So I'm not going to do it because I want to mention a little bit about a question that was mentioned to me in the break. So it's 1, 2, 3, 8, 4. And you keep on going, 2 again, and you'd work it out like that. Perhaps that's the easiest way. But anyhow, whatever you get over here, whatever it might be, we are going to then say, okay, since they both are power base 2, I can equate the n minus 1 equal to whatever I found up here, and then I can solve. So it's really not a problem.
I'm sure you've seen the walk together photo on our page. Please post a caption and like the captions that you think are best. The 3 captions with the most likes will each win a pair of tummy tackies. We'll post the winners on Friday, so get to liking and get all your friends to like too. Now it's time to take a break, so don't go away. We'll be right back. Welcome back from the break. I know you can't wait for the term to end and for the holidays to start. This year we bring you revision sessions from term 1 from the 28th of March till the 6th of April. These will be repeats of all the Learn Extra live shows from term 1. These programs will run from 9 a.m. in the morning till 7 p.m. at night. Go to our website learn.mindset.co.za for all the details. But for now, let's get back to the revision.
Right, question 1 says calculate the sum from k equals 4 to 6 of that particular formula. Now, as I explained to you, it's telling me to start at k equals 4. So I would go along and I'd say 3 to the 4 minus 2. And then to that, I would add 3 to the 5 minus 2. Because remember, I would start with the k equals 4. Then the next one up would be k equals 5. And then the last one I would put in here is when k equals 6, and that would be 3 to the 6 minus 2. Now, if I look at that, I've started at 4 and I've ended at 6, and let's work it out. So this pink one over here will become 3 squared. The yellow one will become 3 cubed, and the orange one will become 3 to the 4. Right, now these are numbers we can actually just work out. So let's just slide this down a bit. 3 squared is 9, 3 cubed is 27, and 3 to the 4 is 81. And if we add those up, we get 117. And this time it's a little bit different. You can see I'm starting at k equals 0 and I'm ending at k equals 15. For the purposes of this question, I could have said k equals 0 and k equals 115. Then you would definitely say to me, there's no way, Lee, I'm going to work these all out and add them up. K equals 0 to k equals 15, you might be tempted, but it's not a good idea because you would be generating, in this case, actually 16 terms. But I will discuss that with you in a little while. So let's have a look what we would do. Because we know the sigma sign actually means sum, let's have a look how these terms will look. So if I take k equals 0, which is my first value for k, it will be 10 times 0 plus 3, so the answer would just be 3. Then if I took k equals 1, and I put it in there, 10 times 1 plus 3 is 13. If I put in k equals 2, 10 times 2 is 20, plus 3 is 23. And I could keep on doing this till I got to my 15th one, which is k equals 15, because that was the last one. And I could then say 10 times 15, which is 150, plus 3, which is 153. Now you can see that if I was going to work out all those terms, the exam could be finished and we could still be working it out. Not such a good idea. So let's go over here and see what we're going to do now. Now, what I would ask myself next is, what kind of sequence is this? So remember how we do it. We have a look and we say, well, what's happening from 3 to 13? Well, we are adding 10. What's happening from 13 to 23? Well, I'm again adding 10. And so on and so forth. But you'll see that if you had worked out, say, one more, it still would be adding 10. And so I can be sure that this is an arithmetic sequence where my A value is 3, my difference is 10. And now comes the exciting part, because after doing that, I've also got to find out how many terms in the sequence. Now, be very careful with this. Let's make it smaller, because when you make things smaller, it's always easier to understand. Let's go back to that one we had earlier on, and let's say if I had k equals 0 to say 3, and I was starting at, well, let's make it easy. Let's just make it 3 to the k. Well, if k is 0, the first term would be 3 to the 0. The next one would be 3 to the 1. The next one would be 3 squared. The next one would be 3 cubed. How many terms do we have? Well, we have 1, 2, 3, 4 terms. So if we look at stopping at 3, but I'm saying there are 4 terms. Now that makes sense, because if I'd started it at 1, I would have had 1, 2, 3. I would have had 3 terms. But now I'm starting it at 0, so 0, 1, 2, 3. So in actual fact, this one I've just put up with a 15 has 16 terms. Now, a good rule of thumb that you can always use to get yourself out of trouble is the following. You can always say, take the top number, subtract the bottom number, and add 1. So if I do that, I've got 15 minus 0, which is 15, plus 1 is 16. So I know that my n would be 16. Let's just check it on this one. Does it work? Well, yes, I would say the top number is 3. I'd subtract the bottom number, and then I'd add 1. And if I do that, I get 4. And were there 4 terms? Yes, there were. Right, let's just take this bit off, because it's got nothing to do with the question. It was just a way of explaining why we're getting that extra term. So a good rule is to always say top number minus bottom number plus 1. Another way to do it is to say it started at 4 and went to 7. Well, you say to yourself, all right, there would have normally been 7 terms had it started at 1, but I haven't got 1, 2, 3 there. I'm starting at 4, so there would actually be 4 to 7. So it would be 3 off the 7, so it would be 4 terms. But I still think it's easier to go 7 minus 4 is 3 plus 1 is 4. Simple, easy, and you won't go wrong. So I think it's a good plan. Right, so once we're here, we want to sum 16 terms. Now, last week, remember, we talked about the formulas. And the formula for a sum of an arithmetic is n over 2, 2a plus n minus 1d. And we're now going to substitute. So your n is 16 over 2. 2 times your a is 3. N was 16. And your difference is 10. And now it's a matter of just working that out. So let's just get a little higher so we can work with it. Right, so that's equal to 16 over 2 is 8. 2 times 3 is 6. And this is going to be 15 times 10. Right, which is equal to 8. And this is going to be 6 plus 150. Which means we have 8 times 156. Right, now that is equal to 8 sixes are 48, carry the 4, 44, carry the 4, and it's 1, 2, 4, 8. And there's my answer of that sigma notation. Let's look at this one. It says calculate the sum of, and what's important here is they're talking about the sum to infinity. Now you remember I said to you today we would work with this formula for sum to infinity. Now, believe it or not, and I'm sure your teachers have already done this with you, that formula comes off your normal SN formula, but I'm not going to get into that because that's just theory, and I'm sure you'd rather be doing questions than doing theory. So let's have a look at what it says there. It says sum from k equals 2 to infinity 8 times a half to the k plus 1. Now, before I even engage with it, if I say to you, start at 2 and end at infinity, how many terms am I going to have? Well, let's think about it. If I said start at 1 and end at infinity, how many terms would you have? Well, I'm sure you're all saying infinite amount of terms. So it doesn't matter if I'm going to infinity and I start at the second, k equals 2. No, because obviously the more, it's infinite. So if it's just like 1 or 2 missing, so it's still infinity. So it definitely is a sum to infinity, even though it does not start at 1. Right, so let's look at the question. Remember what the first thing I did is I worked out some terms to see what they looked like. So let's do that again. Just want to take this off so I've got some room to work alongside. Okay, let's start with the first one. If k equals 2, then the first term will be 8 times a half to the k plus 1, so it's 2 plus 1, which means I've got 8 a half to the third, to the 3. So that's going to become 8, and a half cubed is going to be 1/8. Well, what do we know about 8 times 1/8? It's equal to 1. So the very first term we've got here is 1. Now, if k is equal to 3, I've now got 8 1/2 to the 3 plus 1, which means I've got 8 a half to the power 4. Half to the power 4 is 1/16. And if I tidy that up, I'm going to get a half. So my next term is a half. One more term just to be sure where we are. So let's just get some space again. It's a nice thing about these boards. They really make erasing fun. Right. So if k is equal to, we've done 2, 3. This is now k equals 4. We have 8 times a half to the 4 plus 1. So it's 8 and a half to the power 5 is 1/32. That's over 1, so that goes once and that goes 4 times, and my next term is a quarter. Now, we know it's a sum to infinity. So if it's a sum to infinity, can we get to the end of it? Well, hopefully you all realize there's not a chance, not a chance. Right, let's get that pen up there again. So we know it's going to continue forever. Now, remember what I said to you when I mentioned convergence earlier on. I said to you, when a sequence starts going smaller and smaller, I think I started at 8, then I went to 4, to 1/2. Well, this has gone 1/2, a quarter. So your terms are getting smaller and smaller. And so we know that we're not going to have a problem getting an actual answer. If it had gone 1, 2, 4, then obviously there's no point to summing it because we know it'll be infinite. If you're going to keep on adding bigger and bigger numbers, the answer will be infinite. That's what we call a divergent series. Now, this is convergent. They don't ask me that. That'll come up in one of the later questions. Now, the question I want to ask you, is this arithmetic or geometric? Well, if we look here, 1 to a half would give me negative a half. A half to a quarter give me negative a quarter. So that's definitely not arithmetic. But if I times this by a half, I will get a half. And if I times this by a half, I'll get a quarter. So I can safely say my r is equal to a half. Now, I gave it away by giving you this formula, but you know that the sum to infinity does not work for an arithmetic. It's actually going to be infinity or negative infinity, depending if the terms are getting bigger and smaller, because an arithmetic sequence will not converge. So this is definitely geometric. We know that the a is the first term, which was 1. We've got r, and we know we are looking at n equals infinity. Right, so all we would have to do now is use our formulas. So let's just pull this board up a bit. So we know that that is equal to, the sum to infinity is equal to a, which is 1, over 1 minus r, which is going to be 1, and that's going to be a half. And of course, we know that if we are dividing by a fraction, we can multiply by this one inverted. So the answer of this is going to be 2. Now, does this make sense that if I keep adding these terms, the answer will be 2? Well, let's look at it in a number line. That's the best way to see it. So let's pop a number line down there. Okay, that's 1 and that's 2. And the first thing I'm doing is I'm saying the first term was 1. So we went from here to here. Now I said to you, let's add on a half. Well, if you add on a half, we're going to end up there. So we're at 1.5. Now, if I add on a quarter, I'm there, and I'm going to get 1 3/4. Now, if I add on the next term, which would be 1/8, I am going to get closer to this, but still not on top of it. So I think you can see from the number line, as I'm adding, the things are getting smaller and smaller and smaller, and so I'm never going to pass 2. So that's why I can safely say the sum to infinity is 2. Right, let's look at the next question. Right, the next one says, sum from k equals 1 to n, 6k minus 1 is equal to 320. And they ask you to find how many terms we added. Now, nothing is going to change. We're still going to generate some terms first of all. So let's do that. So over here, if I'm looking just at the sigma part, k equals 1 to n of 6k minus 1. If I put in k equals 1, I'm going to get 6 minus 1, which is 5. If I put in k equals 2, I'm going to get 6 times 2, which is 12, minus 1, which is 11. And if I put in k equals 3, I'm going to get 18 minus 1, which is 17. And I could work out a few more. I don't know what term n is. I suppose I could find it if I went and just called it 6n minus 1. But for the purposes of this exercise, it wouldn't really help us here. So what's happened? I've added 6 to get there. I've added 6 to get there. And so I can safely say this is an arithmetic sequence where my a is equal to 5, my d is equal to 6, n is missing, and I know that the sum of n terms is 320. Great, so now we're ready to work it out. Remember what I said to you, it's always a good idea to make a list of what you've got, because then when you look at your formula, you can see how many knowns you've got, how many ones you haven't got. So we can see of the 4 things in the sum formula, we've got 3 of them, which is a very good situation to be in. So Sn equals n over 2, 2a plus n minus 1 d. Right, so let's go for it and look at it slowly. So we know that the answer of this is 320. We don't know what our n is. Our 2 times a will be 10. We don't know what n is, so we leave it alone. And our difference is 6. How many unknowns have we got in this equation? Well, I'm sure you can see that the only unknown is n. However, we can have an exciting n. It's going to have something different about it. Let's have a look what happens when I tidy up. Right, so I have 320 equals n over 2. Let's make this bracket look a little bit better. So we have 10 plus, and I'm going to times the 6 in here and the 6 in there. So I'm going to have 6n minus 6. Now, I don't like to work with fractions, and I'm sure you don't either. It just increases our chances of having a problem. So what I'm going to do is I'm going to times both sides of this equation by 2. So that 2 will take that one out. And I've now got 640 equals 10 minus 6 is going to be 4 plus 6n. Now, of course, you're saying, well, you didn't need to times by 2. Yes, you're quite right. I didn't need to because it would have divided nicely out. However, it doesn't always do that. So it's a good idea to rather eliminate that fraction, and then it makes it a bit easier for you. Right, let's move it up. So what have I done? Oh, yes, I've left off the n in front here. All right, so what I've got is 640 equals 4n plus 6n squared. Now, it's so nice because everything here is divisible by 2. So I can go 320 equals 2n plus 3n squared. So it didn't matter if I did a little scenic route, but I'm pretty sure that my arithmetic would be right. So now, because it's a quadratic, we know to bring everything to one side. And then we're going to do our favorite occupation, namely factorize. Now, if we look at this, we've got a 3n in the front and a 320 at the back. So I think 320 obvious possibilities would be 32 times 10. And don't go looking for hard ones, because often they are the simple ones. So it's usually something that's manageable. Of course, if all else fails, you can use your quadratic formula. But in actual fact, I would suggest look for the obvious first. And if I do that, I can say 0 equals, and I'm going to make it a trinomial factorization. So I've got 3n and n. I'll put the 10 there and the 32 there. That makes that a plus and it makes that a minus. So n is equal to minus 32 over 3, or n equals 10. Now, what does n stand for? N stands for the number of terms. Can you have, whoops, I just went a little bit skew there. Can we have a number of terms that is negative, first of all? I'm sure you haven't heard of a negative term before. Well, a negative number, yes, but not a term number. And we're certainly not going to have a fractional term either. So again, there would be a problem there. So I can safely say this one is not applicable, and this one's right. Now, the question I'm sure that is springing into your minds right this moment is there a time when you can get two answers? Yes, there most certainly is. So if my answers had worked out to be n equals 10 and n equals 5, well, both of them are possible. And when that happens, it's usually when your sequence is going across positive and negatives, and the terms counteract each other. So if there are whole numbers, then certainly you can have two answers for your sum. Right, so that's a nice question. We've answered it, and we've got the solution. Right, let's look at question 5. Now, this one says, given the geometric series 2 times 5 cubed plus 2 times 5 to the 4 plus 2 times 5 cubed, etc., show that the series converges. So, to check out for convergence, we need to find our ratio or our R value. Now, remember from last week, R is always determined by taking any two consecutive terms. So in this case, we've got term 1, 2, and 3, so we might as well take term 2, divide by term 1. So if we do that, we've got 2 times 5 to the 4, divided by 2 times 5 to the 5. The 2's divide into each other, and then from our exponential laws, we know that this will become 1 over 5, because there are 4 there and 5 down there, or you can go 5 to the minus 1, which is equal to 1/5. Now, what was the condition for convergence? We learned in the table just now that if R lies from minus 1 to plus 1, it converges. Well, is 1/5 between minus 1 and plus 1? Yes, it is. So we can safely say this series converges. Right, now it says calculate the sum to infinity of the series. Okay, so the sum to infinity, I'm going to work relatively quickly. We've already done one like that, so I'm going to go a little bit faster. So my A would have been, I think it's 2 times 5 cubed. Decided to make a mess on the board. Okay, it's 2 times 5 to the 5 over 1 minus 1/5. And we can tidy that up and work it out. I'm not going to do that because that's just donkey work. Important is this last part of the question, and that's where I want to get to. Then it says, calculate the sum of the first 8 terms correct to 2 decimal places. So they're giving me permission to use my calculator. And so in actual fact, I could have used my calculator here. So let's do it so we can speed up a bit. Remember that if we wanted to, we could rather write this as 2 times 5 to the 5 over 4/5. And of course, you could have done it normally, but I'm going to just bring the calculator up, and we're going to do it that way. So we've got 2 times 5 to the 5. Fraction button, oh dear, sorry, I'm getting very adventurous in my old age. Okay, 5 to the 5. And then I want to space bar down, I forgot about that, divide by 4/5. So fraction button 4 over 5 equals. That's my answer, and they said I could have to so many decimal places, so let's just do it. It's 7812.5. 7812.5. Right, now the next one asks me for the sum of 8 terms. Now last week we didn't work with the sum of a geometric, so it's a good opportunity to do that. So the sum of 8 terms, remembering that our R is 1/5, the best formula to use for that is going to be A, 1 minus R to the N over 1 minus R. Right, so let's get some space going. So it's equal to your A is 2 times 5 to the 5. 1 minus 1/5 to the 8, and that's 1 minus 1/5, which is 4/5, which we're going to stick in the calculator and get an answer. Okay, I'm going to be lazy and leave it there because I really think I'd rather finish the question than leave it halfway. So it now says to you, use your answers to B and C. So your answer of B is here, and this would have been your answer of C. To calculate this next one, now notice what they're doing. They're summing to infinity, but they're starting it from k equals 9. Now remember, the original started at k equals 1. So in actual fact, what they want you to see is the following, that the sum of this thing equals actually the sum to infinity of the original minus the sum of 8 terms starting at 1. And so you would take the answer of your sum to infinity, which is your 7, 8, 1, 2, 5, and you'd subtract from it the answer you got for C, and you get the answer. But they help you a bit. So that just gives you an idea. I just wanted to rush that because I think it's an important skill that you've got over there.
We've come to the end of our show. Thank you so much, Mindsetters, for joining me and for chatting to me during the show. Remember to visit our website, learn.mindset.co.za, to get your notes and to watch the videos from the term. Goodbye.